Hey GeoKids, it's Mrs. Fallon again. I'm on lesson 5.6 on page 150 of your student journals. All right, so in this lesson, we are going to actually add two more theorems to our list of how to prove triangles are congruent. So, proving triangles congruent. All right, so if you remember, we have side, side, side. So that's where if you can show that all three sets of sides of two corresponding triangles are congruent, then the triangles are congruent. You have side, angle, side. So again, what this means is you have two sides and then the angle that makes up the two sides. So the angle in between, if you can show those three sets are all congruent, then the triangles are congruent. Today we're gonna add ASA, which is angle, side, angle. So it's kind of like side, angle, side, except it's the exact opposite, right? So it's like the converse. So we're going to do two sets of angles that are congruent and the side that's between them. So if you notice, here's, if they show you that C and F are congruent and A and D are congruent, and see that the side AC is congruent to side DF, and that's the side that's between the two sets of angles. And then the last one we're going to show is angle, angle, side. So we have all four of these proofs. So angle, angle, side is very similar to the side angle, except if you notice, the side is not located between the two angles. So this is what it would look like. You'd have angle, so angle A and angle D are congruent, angle C and angle F are congruent, but notice BC and EF are congruent. And that side does not fall between the two angles. It's kind of like separate. So when I look at it, I have angle, angle, side, angle, angle, side. And then let's not forget, we also have that HL, which is hypotenuse leg, but remember that's only for right triangles. If we can show in a right triangle, two sets of right triangles, that the hypotenuses are congruent and one of the legs are congruent, then we can show that the triangles are congruent. All right, so now, excuse me, now that we know that we have all four, well, five kind of sets of theorems that we can use to kind of prove triangles are congruent, what we're going to do on this page is just kind of start recognizing. So I'm going to give you a congruent statement. I'm going to do the odds here. So I'm going to tell you triangle GHK and triangle JKH. We're going to decide whether there's enough information to prove that the triangles are congruent. If so, state which theorem. So remember, the theorems were side, 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 angle, side, and now we have angle, side, angle, and angle, angle, side. All right, so let's pay attention to this. So we have J and G. So we're talking about these two triangles here. So I'm going to highlight this one over here. So we have J and G. We have H and K. So what they're going to do on this one is also pay attention to any of that hidden information. So remember, we have this side and this side are congruent, but we also know because of that reflexive property that this side is congruent. So given all of this information, do we have enough to prove with one of those theorems? Because I'm not going to use HL because of the fact that it's not a right triangle, so I don't need to worry about that one. All right, well, I have two sides. Do I have three sides? No, so I can't use side, side, side. Do I have side, angle, side? I've got an angle and I don't really have side, angle, side, because I have two sides, but I don't have the angle in between them. Okay, so that one's ruled out. Do I have angle, side, angle? So that means I have two angles and the side in between. Well, I have two angles, but I don't have the side in between, so I can't work that. So that one doesn't work. How about angle, angle, side? Well, if I have angle, angle, side, that would work. And on this one, angle, angle, side. So it looks like, yes, this will work. Yay. Our triangles are congruent by angle, angle, side. And that's kind of what I want us to be able to do, is start recognizing how we know those triangles are congruent. Let's look at number 3. And so number 3 has us looking at two triangles here. So we have this one, and then we have this one. Do you notice they both share KL? Okay, so I'm going to get the reflexive property. It's not a right triangle, so don't worry about HL. But let's pay attention to what we do know. We know this piece and this piece. So the problem with this particular congruent statement is we have we have this angle and this angle and this side and this side, but the part that's marked as congruent is just this piece here and this piece here. So I have to go with no on this one. And the reason why is because I don't know this whole side is congruent to that whole side, because I only have this piece and this piece. And so the way it was kind of labeled doesn't give us enough information, because I don't have side, 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 because I don't have three sides. I have side, angle, side, because I have, even if this whole side was true, I'd have to have the side, the angle, and then this side in order for it to work. Angle, side, angle. No, because I have angle, side, but I don't have another angle. And then I have angle, angle, side, but I only have one set of angles. So none of those theorems are going to work for me. So we're going to call that a big no. All right, so then we're going to also ask us to be able, you to be able to do is to, you know, kind of without giving a picture, could you kind of determine if these triangles are congruent? So we have triangle LMN is congruent to PQR. Decide you can, if you use the given information to prove that the triangles are congruent. So I'm just going to draw two triangles. It didn't tell me they were right triangles, so I'm just going to draw them as like regular. LMN and PQR. All right, so let's mark what we know to be true, and let's see if this kind of holds true. So we have M and Q are congruent. So M is congruent to 2. You can put the dash in here if you want, don't have to. N and R, so N and R. And then NL, side NL, and side RP. All right, so I have, it looks like I have two angles and a side. So the only theorems that deal with two angles and a side is this one. Well, these two, angle, side, angle, and angle, angle, side. So angle, side, angle, or angle, angle, side. Let's see if I have either one of those. Well, it looks like I have an angle, and a side. An angle, and a side. So I'm gonna say it's this one, because I have enough information, and the side is not between my two triangles. So my explanation kind of is my picture, but my explanation is the fact that I have angle, angle, side. All right, I'm gonna leave the even ones for you guys to practice, and that way if you have questions, you can bring them to class. I wanna go over a couple proofs with these theorems. So let's turn to page 152. All right, let's do number 7. So in this proof, we are proving the triangles are congruent by ASA. So we're using the angle side angle theorem. So that's kind of gonna be our goal. That's how we're gonna end this proof. So let's start with our given. AC bisects angle DAB and angle DCB. Given. All right, I want you to find that sheet that I had you guys kind of write before. Remember our proof writing tips? And I gave you this one. I talked about this one. It says, if given an angle bisector, if given a segment bisector. So we were given that AC bisects angle. So we're talking about angles here. So if we're given an angle bisector, what does that mean? Well, we can conclude then if we are told that we have an angle bisector, then we know that two sets of angles or a set of angles are going to be congruent. In this scenario, we know that it bisects DAB. So DAB, that means this angle and this angle, it bisected. And it bisected angle DCB, which means this angle and this angle. So I like to use numbers when I label them, just because it's easier for me to kind of keep track. But again, you can use like the 3 letters. You can call this, instead of calling it angle 1, you can call it angle BAC. It doesn't really matter to me. I'm going to use numbers. All right, so I'm going to say, because this was my given, I know that if I'm given an angle bisector, I know sets of angles are congruent. So I'm going to say angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. And the reason I know this is because of definition of angle bisector. That's what it means to be an angle bisector. It means that it's bisecting the angle or cutting it in half. All right, so remember our goals for writing proofs. We look at the given, we use the given, right? So we use every piece of the given, and now we look for hidden information. So I told you we're going to use angle, side, angle. And so we just did two angles, right? We just showed that two angles are congruent. We need a side. Do you see the hidden information here? Do you see the side that's congruent? Hopefully you're recognizing that this is the reflexive property. And so I know that that side is congruent to itself. And that's our hidden information. And again, if you want to remember on our hidden information on our sheet, we had the reflexive property and the vertical angles were the two that are kind of the most common that we're coming across right now. So my reasoning is the reflexive property. And now since I said a side is congruent, it's side angle, now I can end my proof. And I can say triangle ABC is congruent to triangle ADC. And my reason is that angle, side, angle. So that's how you're going to see this proof or proofs using this kind of theorem. Now, obviously, not the exact same one every single time, but that's one example of them. Let's do another one. This time we're going to use angle, angle, side, so we haven't done one of that one. So angle, angle, side. All right, let's start with our given. O is the center of the circle. And we know that angle N is congruent to angle P. All right, so we know O is the center of the circle, so that's obviously important information. So we got to think about what that tells us. And we have N and P are congruent. All right, so I have an angle. So I'm one step out of my 3 steps. I have one step already kind of given to me. Now, I didn't mention anything on here about anything given if we were given something as a center of a circle. And the reason I didn't put that on that sheet is because it's not a really common one. But I like that this is something that we're going to go over in this video because there are always exceptions, right? There's always additional things in terms of proofs. There's millions of ways to do triangle proofs. And so on that proof writing tip sheet is kind of the most common ones, not a comprehensive list of all possible choices. So you have to think, why am I telling you that O is the center of the circle? What is that? Why is that important? So look at your picture. If O is the center of my circle, think about what we know about this length and this length and this length and this length. What do we know about all of those measurements? Well, if O is the center, then all of those measurements are called radii, right? They're all a radius of the circle. And in a circle, by definition of a circle, we know that all radii are congruent. So I'm going to say NO is congruent to QO, and I'm going to say MO is congruent to PO. I actually might have too much information here because I only need one side, but that's okay. So I have this side and this side, and I have this side and this side. All right, so the reason I'm going to do this is I'm going to say, you could say definition of radius. I'm going to say, I don't know, all radii of a circle are congruent. It's really just your justification as why you know that's true. All right, so we use this piece of information in our given, and obviously we use this piece. I marked it on my diagram. So I don't have a proof that says SSA. I don't have one. There isn't one. Number one, if you spell it the other way, ASS, it spells a bad word, and so therefore we're not going to use it. And that's how I always know that that's not a valid, triangle congruent theorem. So I have to find something else. And so what I'm looking at is if I know this, so I kind of marked this wrong. So I'm going to fix this right now. I'm going to change this to show that all of these are congruent to each other because technically they're all radii, correct? And so therefore we know that if this is 5, then all 4 of them are 5. Or if this is 12, and then all 4 of them are 12. So I'm going to use the same markings. I should have used the same markings on all of them. All right, now I want you to look at like this triangle here. Okay, let's just pay attention to one of the triangles. If we knew those two sides are congruent, what do we know about those two angles? So this proof is a little bit harder than the other ones because we have to kind of, it's not as common in terms of the rationale. But if we know those two sides are congruent, then we should know these two angles are congruent. And the reason why is because those are base angles. So I know that this is congruent to this. Likewise, if on the other side, if I know that these two sides are congruent, then these two angles are congruent. And since all four of those sides are the same measurement, then all four of those angles have to be the same measurement. All right, so I'm going to say, follow me here, angle M is congruent to angle Q. And the reason why is because of that base angle theorem. We've used this theorem a couple times. It's worthwhile. I mean, if you want to add it on our sheet, as just kind of things to kind of pay attention to. It probably wouldn't be a bad idea. It's not one that I think is like super, comes up a lot, but it is something that we've seen now a couple times. All right, so now that we've got the base angles theorem, I've got this angle, we've got the side, we should be able to end our proof. So triangle MNO is congruent to triangle PQO. And the reasoning is I have angle, angle, side. Angle, angle, side. So I have the only one that's going to work here is that one. All right, I would encourage you to practice these proofs. Go on to big ideas, do some lessons. The only way you're going to get good at proofs is trying them on your own. All right, bring any questions you